Assalamualaikum and hi. Our lecture today is chapter limits. For lecture 1, we have two objectives. The first objective is state limits of a function f(x) as x approaches a given value a. The second objective is state the basic properties of limit. Now look at the definition of limits. A function f(x) is said to approach a constant L as a limit when x approaches a as below. We write as limit f(x) as x approaches a equal to L. We are looking the behavior of f(x) as x comes closer and closer to a. What does it mean is when x gets closer to a but x not equal to a, f(x) gets closer to L. Read as the limit of f as x approaches a is L. Here are some notation that you can see in this chapter. This one means x approaches a from the right. This one means x approaches a from the left. And then this one means x approaches a from both sides. We can evaluate the limit by using intuitive method and properties. Now look at the intuitive method. Draw a table of values of x versus f(x). Then select several values of x close enough to a. Okay, observe the pattern of corresponding f(x) values. And then the last is guess the value of f(x) when x is approaching a. At example 1, find limit x squared plus 1 as x approaches 0. First, draw a table like this. Put x here, and here is f(x) equal to x squared plus 1. Then select several values of x. X should be approaching 0 from the left and from the right. For example, we can use -1, -0.5, -0.25, and -0.001. This is x from left to 0. And 1, 0.5, 0.25, 0.001. This is x from right to 0. Okay, and then find the value of x equal to -1. Y equal to -1 squared plus 1 is 2. X -0.5, fx is 1.25. X -0.25, this is 1.0625. And for -0.001, fx is 1.000001. When x is getting closer to 0 from the left, fx here is getting closer to 1. When x is approaches 0 from the right, for x equal to 1, fx equal to 1 squared plus 1 is 2. For 0.5, this is 1.25. For x 0.25, fx is 1.0625. And x equal to 0.001, fx is 1.000001. Okay, when x is getting closer to 0 from the right, fx is getting closer to 1. Therefore, the limit x squared plus 1 as x approaches 0 is 1. We can write as limit x squared plus 1 as x approaches 0 is 1. From the graph of fx equal to x squared plus 1, this is graph fx equal to x squared plus 1. We can see that when x approaching 0 from the right here, fx approaching 1. And then when x approaching 0 from the left here, fx approaching 1. Thus, we can write as limit x squared plus 1 as x approaches 0 equal to 1. For first property, if fx equal to c, where c is a constant, then limit fx as x approaches a equal to limit c as x approaches a. The answer is c. For example, limit 5 as x approaches 3 equal to 5. Second property is, if fx equal to x, then limit x as x approaches a equal to a. Example, limit x as x approaches 3 equal to 3. Third property is, if fx equal to x power n, where n is a positive integer, then limit x power n as x approaches a equal to a power n. For example, limit x cubed as x approaches 2 equal to 2 cubed. The answer is 8. Number 4, limit fx plus or minus gx as x approaches a equal to limit fx as x approaches a plus or minus limit gx as x approaches a. For example, limit x power 5 minus 10 as x approaches negative 1 is limit x power 5 as x approaches negative 1 minus limit 10 as x approaches negative 1. This one is property number 3. This is negative 1 power 5 minus this is property number 1. Limit 10 is 10. The answer is negative 11. Property number 5. Limit fx times gx as x approaches a is equal to limit fx as x approaches a times limit gx as x approaches a. For example, limit x squared minus 5 times x plus 1 as x approaches 4 is equal to limit x squared minus 5 as x approaches 4 times limit x plus 1 as x approaches 4 is equal to 4 squared minus 5 times 4 plus 1. 4 squared is 16 minus 5 is 11. 11 times 5 is 55. Property number 6. If c is a constant, then limit c times fx as x approaches a is equal to c times limit fx as x approaches a. For example, limit 5x cubed as x approaches 10 is equal to 5 times limit x cubed as x approaches 10 is equal to 5 times 10 cubed. 5 times 1000 is 5000. Property number 7. Limit fx over gx as x approaches a is equal to limit fx as x approaches a over limit gx as x approaches a, provided that limit gx as x approaches a not equal to 0. For example, limit x over x squared plus 10 as x approaches negative 5 is equal to limit x as x approaches negative 5 over limit x squared plus 10 as x approaches negative 5 is equal to limit x as x approaches negative 5 is negative 5 over limit x squared plus 10 as x approaches negative 5 is negative 5 squared plus 10 Here is negative 5 over negative 5 squared is 25. 25 plus 10 is 35. Is equal to negative 1 over 7. Property number 8. If f is a polynomial function, then limit fx as x approaches a is equal to fa. This is by using substitution. Substitute the value of x equal to a into the function fx. For example, limit 3x squared minus 4x plus 10 as x approaches negative 2 is equal to 3 times, substitute x equal to negative 2. Here is negative 2 squared minus 4 times negative 2 plus 10. This is equal to 12 plus 8 plus 10. The answer is 30. Property number 9. Limit nth root of fx as x approaches a is equal to nth root of limit fx as x approaches a, where n is a positive integer and fa greater than 0. For example, limit set x plus 4 as x approaches 0 is equal to set for the limit x plus 4 as x approaches 0. This is equal to set, substitute x equal to 0, 0 plus 4. This is equal to set 4. The answer is 2. Note here, by substituting a in the limit fx as x approaches a equal to L, then L is the exact value of fx when x equal to a, and the approximate value of fx when x approaches a. Thus, the limit is equal to exact value. Now we look at the limit of the rational function. For a rational function, the limit can be found by using substitution method, provided that the denominator is not 0. If fx and gx are polynomials and c is any number, then limit fx over gx as x approaches c equal to limit fx as x approaches c over limit gx as x approaches c. This is by using property number 7. And then substitute x equal to c into the function fx and function gx. This is equal to fc over gc, provided gc not equal to 0. Look at example 2. Find the limit. For a, limit 1 over x squared as x approaches 1 is equal to 1 over x squared. Substitute x equal to 1, 1 squared. This is 1. For b, limit 3x plus 4 over x minus 2 as x approaches 3. This is equal to 3 times the value of x is 3 plus 4 over, substitute x equal to 3, 3 minus 2. This is equal to 9 plus 4. The answer is 13. Please do the exercise. I give you the answer. For A, the answer is negative 2 over 9 and B is 18 over 31.